Okay guys, let's get into these examples. So here's our first example. Here does the point -2, 7 lie on these particular lines. So the easiest way to do that is to substitute these values. There's our x value and our y value just into the equation. And then if one side is equivalent to the other, it lies on the line. So let's do it. So we've got y equals -3x plus 1. So we want 7 to equal -3 times -2 plus 1. Okay, I'm just going to chuck some little brackets around there. So we're going to leave the 7 on its own. Okay, -3 times -2. Now it's two negatives multiplying together, so it's just a +6 plus 1. +6 plus 1, 7 equals 7. The left-hand side equals the right-hand side. So yes, is our answer there. Okay. Over here we've got 2x plus 2y. We don't need to rearrange this equation. We can just substitute straight in. So we're going to have 2 times -2 plus 2 times 7 equals 1. So this is what we want to have happen. So 2 times -2, it's a positive times a negative. So we're going to have -4 plus 14. We need that to equal 1. -4 plus 14, well that equals 10. So the left-hand side does not equal the right-hand side. So this one is a no. Okay, let's get the next one done. Let's find the gradient and the y-intercept for these linear relations and sketch each graph. So we're not going to sketch these particular graphs. We're just going to find the gradient and the y-intercept for them. I'm just going to cross that little bit out. So our first one, our gradient and y-intercept. Well, this first one's pretty easy. We just need to identify the bits and pieces. So here is our gradient. So m equals 2. This one that I've just circled is our y-intercept. B equals -1. Okay, so that one was quite simple. Let's look at the next one. We have 2x plus 3y equals 3. So we need to move the x to the other side. So I'm going to subtract from both sides. Which is going to leave me with 3y equals -2x plus 3. Okay, but I want y on its own, so now I need to divide everything by 3. And when I say divide everything, I really do mean divide everything. Alright, so now we have y, because we've cancelled out those 3's. Then we've got -2 over 3 x plus 1. Okay, so now our gradient is our -2 over 3. And then our y-intercept is +1. Alright, so that's a very quick look at doing that particular one. Now we're going to do some graphing as well. So the first one, super easy. This is our M, this is our B. Alright. So all we need is let's call that 8 or -8. Let's call this one over here 4. You don't really need to put every mark on there. just as long as you have the two main points lifted. Alright, so why have we gone to 4? So our gradient is 2. So our rise over run is 2 over 1. Okay, so we always have to have a rise over run, and if it's a whole number, it can be written as over 1. So every 1 unit across, we're going up 2. So if we do that from -8, we go across 1 and we go up 2, that gets us to -6. So 1 minus 6 would be that point. Then we go across 1 again, so we've got 2 as our x-coordinate, but now we've got -4. Then we have 3 as the x-coordinate, and then -2, and then 0 and 4. So that's how that's working, in case you were concerned. We'll be able to see it a little bit better on a different graph, I think. We grab our ruler out. We draw our line through the points. And there we have it. Okay. This next one might be a little bit easier to see. So first of all, we're going to add 3x to both sides. Alright, leaves me with -2y equals 3x plus 6. Then I want to divide everything by 2. So I end up with y, or it should be -2, sorry. Okay, so y equals -3 on 2, so we're going to have a downward looking graph, plus 3, simply because, it should be -3, my bad. Because we're dividing by -2, so we get -3, so that's our y-intercept. So I'm going to go down, let's go 1, 2, 3. Okay, and I'm just going to go across a couple. We're going to see this a little bit more in action. So what we're going to do is, this is our rise over run here. Alright, so that's our rise over run. So the easiest way is to go towards your x-intercept. So if we go backwards this time, it'll work out pretty well, I think. So we're starting at -3, because that's our y-intercept, sorry, y-intercept. So for every 2 across, so if I go across 2, so 1, 2, I need to go up now, because I'm going backwards because it's negative. I need to go up 3, so 1, 2, 3, and that gets us straight at -2 for our x-intercept. We grab our ruler, swing it around so that it lines up with these 2 points, and do the same thing. Okay, so there's our line there. So theoretically, this should not be brand spanking new to you, so you should have a little bit of an idea of what's going on. All right, last one. These are our special lines. Y equals 2. All right, there's 2. I'll pop that line in very easily. This is just a vertical line. Find where it crosses the y-axis, and voila. Then we've got x equals -3. So I'll do the same thing, only this time for the x-axis. And then the last one is minus a half x. So it's actually going to go through the origin because there's no y-intercept. All right, so it's negative. So for every 2 units backwards, it's going to go up 1, or for every 2 units forward, it's going to go down 1. So if I go 1, 2, I need to go down to here. If I go back the other way, 1, 2, I need to go up to there. So it's going to be a downward facing line that's going through the origin. Then I get my trusty ruler. Get that all lined up. Draw the line in. I can get rid of the ruler now. And there we have it. That is the examples for graphing some straight lines. Rewatch these as many times as you need to. Hopefully they help, and good luck with your questions.